HBase. HBase is also built on the concept of NoSQL. And NoSQL, when I say, what is the abbreviation of it? Not only structured query language. So SQL we already know, not only structured query language. And HBase is built on a paper wide project, just like Hadoop, MapReduce, HDFS is based on GFS paper, Google file system. So this HBase thing is based on big table paper. So it is based on this concept. Again, big table paper, their contribution, we have Google contribution more in this wide project of big table. So NoSQL, not only structured query language, and we have seen how many different products are there. So quickly recap the name. So landscape, we have many things. DynamoDB. This is designed by Amazon Web Services. Then Cassandra. This is by Facebook. Walmart. This is by LinkedIn. Then MongoDB. Here we have MongoDB Foundation. MongoDB Foundation. Then CouchDB. Then HBase. This is a Hadoop distribution service. Okay, so I can call this as an ecosystem because we'll be writing up this information in Hadoop components. Then OrientDB. This is for graph database. Now we know Cassandra, MongoDB, and HBase. These are the important one. If you're working with any foundation or any distribution, this three is a majorly known NoSQL topic. So if I want to store any low latency of information, I rely more on the NoSQL nowadays. I will differentiate between SQL, and NoSQL. So we'll see the difference between these two different topics. Cassandra is good for writing purpose. If I want to write a huge amount of data, if I want to read that information, HBase is better. And cases wise, we have seen that Facebook Messenger is using this HBase to run their 100 billion query just in 1 second. So this is their scalability. Now, a quick difference between SQL and NoSQL. NoSQL and SQL. So not only structured query language and structured query language. If you read the name itself, if we abbreviate this NO term, this is not only, which means your HBase is going to be, okay, your HBase is going to be a schemaless. Because since we're learning HBase, that's why I'll relate here with HBase. HBase is going to be a schemaless. What do we mean by schemaless? I will give an example. SQL is a schema based. Then second point for NoSQL, that this is good for structured data, semi-structured data. Even in many cases, we can store unstructured data also, but 80 to 90% we're dealing with this structured and semi-structured data. So I'll write this two names. SQL is only designed for structured query language and structured types of data, like relational data, where my information is matching with a schema, or I can refer them as data and metadata. Then NoSQL third point, that they are column oriented database. they are column oriented database. They are row oriented database. They're column oriented database. They are row oriented database. Okay. Now we have seen difference number one, difference number two, difference number three. This is the basic difference between NoSQL and SQL. Now here your scanning will happen vertically because column oriented database means if I write, this is how their entry will happen, or their reading will happen, or their writing will happen, or their query will work. This is vertical. So this is what I'm saying in point number fourth. When you run any query, they scan that information vertically. And if you run any query in SQL, this is horizontally. This is a horizontal operation. We'll see in example wise, okay, how what vertical and horizontal we can relate here with this query. First, I will check the point number one, is schema less. Okay, here I will check the schema less. Suppose I'm creating a table. So create a table in HBase. So if I'm creating a table in HBase, I'm not writing any schema. Let me not directly go to HBase. Let me create a table first in SQL so we can compare from there. Suppose I'm creating a table in MySQL, which is a one kind of relational database management system or relational database management system. Here I said create. So this is my DDL, create table, table name. That table name is, let's say, transaction. Then I'll give transaction ID, which is integer, and I'll give transaction amount, which is double. Now, when I'm creating this table in MySQL, this, if you do not define this two things, integer and double, integer TID is followed by integer, amount is followed by double. If I do not give, then this will throw me exception saying syntax exception, or schema is not matching exception, or schema missing exception. So we have some problem here. That's why I'm saying this is a schema based operation. If I skip this point while creating table in HBase, I can create it. HBase will not ask me, or many NoSQL tool will not ask me to provide the schema. That's what I'm saying, schema less. But what is the benefit? That's okay. I can create the column name without a schema. But what is the benefit here? Benefit is in single column, right? If it is TID, you can store integer also. You can store string also. You can store double also. You can store any data type. That's the beauty of your column which you create in HBase or some of the NoSQL tools. So point number 5, I'll write with this. Point number 5 is they work with the concept of denormalization. Okay, they are denormalized because they're not following the typical ACID properties and the proper structure of normalization. Here they work with the concept of normalization. This is what we say normalization. We'll have to keep same information in one column, not other data, right? So this is our point number 1. We'll be creating our table like this. Structured, semi-structured, mainly we handle JSON types of data in NoSQL. Here we handle data in a blob, text format, comma separated, text delimited, column oriented database. So we'll see the point number third now. Suppose I have a table and my table transaction. Okay, so I will run a query select a star from table name. I'm running one DRL, data retrieval language, select star from table name, which is transaction. Select star from transaction, and I'm getting this result: TID, transaction ID. This is my column name, transaction amount, and let me keep one more column as their transaction date, T date. TID, I have suppose total 7 result. Transaction ID is some 22435137105249324. Amount is uh, transaction amount is total, let's say $1,000, 1,200, 80,000, 2,300, 5,000, 10,000, 9,900. And there are some date. Okay, I'll write one date which are stored in this format: YY, DD. If you want to store uh, you want to store the time also, so we create this as a timestamp which is having HHMMSS just next to this HHMM and SS. We know that how timestamp stores the data, and I have so many information in this format. Now when I run a query, and suppose this data size is total. So likewise I have likewise, let's say I have total 1 million result, 1 million TID amount and transaction date, 1 million total row, and last row is somewhere 578. These are unique always. Transaction ID will be unique. When I'm running a query, and we'll have some amount on this, some data on this also, and this amount is 1 lakh. This table is currently having total data size as 3.2 GB. Okay, so this table is having total data as 3.2 GB. When I run a query, select a star from table name. Okay, select star, or let's say I'm looking for the TID. So I'll say select T underscore ID, transaction ID from table name, which is transaction, where date, I will write T date is equal to some date transaction I'm looking for. Let's say I'm looking for a transaction of 2019 YY DD at 12 o'clock. How many transaction has made on this time? When I run this query, what this query will do, it will try to scan my complete table, which is this transaction table, and this transaction table is having how much data? 3.2 GB. It will try to scan the complete data, and then it will check this row. So in this row we have this result available. We have some transaction ID, we have some amount and some date. Since this we are asking only to bring the TID, after running the query, it is checking first column, second column, third column, and scanning the complete row and giving me the result as, let's say, 728. because their scanning is happening row wise. So if I have 70 column, and I'm just looking for one column result, okay, 70 column, column 1, column 2, column 3, likewise total 70 column, and I have so many rows here. Suppose I'm looking for one specific row with this condition. What they do, if I'm giving for this TID also, internally I'm talking about, your row oriented database will check for all the column. They will check the all column, and based on this condition, then they will give you result maybe for C3 or C2, whatever you are writing here. If you're writing a star here, instead of CID, TID, if you're writing a star here, it will bring the complete row. If you're writing any specific column name, then it will give that column result based on the row. So if their scanning is happening row wise, and they're checking for complete column, which is a horizontal operation like this. If I run the same query in NoSQL or in HBase, so what they do, there are 70 column or 700 column or 7,000 column, I do not care. If I run a query, they'll specifically target that column only. So if I have 70 column, again, like just this, and I'm looking for maybe column number 5, so they will check this column only. They'll not check the rest of the column. We'll see how this logic has been built over on HBase. Okay, but why this is faster? I'm currently talking about the fast business done by any NoSQL series. So NoSQL is anytime faster than SQL. The reason is simple. They're column-oriented database. They are row-oriented database. And this is the reason, if you ask me, why we are focusing more on the Parquet side in Hadoop. Because Parquet does the serialization based on column, not based on row. Your Avro is a row-based serialization technique, and Parquet is a column-based serialization technique. So most of the time, whenever we want to serialize the data, we try to serialize that using Parquet so that the query can be faster. Though they are taking more space in hard disk, that is the second case, because always we focus on two things, time and space trade-off, right? Always my algorithm is based on time and space complexity or trade-off. So if somebody is saying me, I can take earlier this is taking, this time is total, um, some unit of time, okay? So some unit of time. And this unit of time can be, this unit can be in microsecond, millisecond, nanosecond, right? Or maybe second. This space is a RAM space. And this query is taking, let's say, total 50 seconds currently, the query which I'm running. This query is taking total 50 seconds. And somebody says me, I can decrease the time, but I need some more space in your disk or in your RAM. I'll say, perfect, no problem. Take the more space and brought this time down from 50 seconds to 5 seconds. Can you scale 10 times? Then if this is done, then I'll again try to optimize. Can you do this in 2 seconds? This is what happening in your system. You're trying to scale, and scale. Once your code is stable, your product is live, you're always doing the scaling. So that one query is taking this much time. How tomorrow if I run the same query, how can I decrease it? Because data is a never-ending business. You cannot say data generation rate will stop after 2 years. It is like you're saying population will stop after 2 years, which cannot happen, which can never happen. It's not logical. Population will increase, so the data will increase. So so many connections we have with this. Uh, Currently, we're talking about the schema less and column orient column orientation database. How the scanning thing will work. Vertical horizontal is proportional with the point number third only. Denormalization, normalization we have seen there in this. So when I say schema less, does that mean in HBase I do not have any data type? If you're thinking that, so you're right. HBase does not have any schema concept. By default, they internally store their data in byte array. So HBase does not have any data type, any schema type. By default, they will store their data. By default, they'll store their data in byte array form because they work with a cell based operation. Okay, so this is one thing uh, to remember in HBase. It does not have any schema like integer, boolean, date, timestamp, string. I'm not writing anything. Even I'm not writing this byte array also. Internally, they store the data in byte array. This is the by default type of a schema. Then before going to HBase concept, why should I am working with HBase? When already I have one distribution, one storage available in my system, which is HDFS. So we will have to compare HDFS versus HBase. Because if this point is not clear, then I cannot directly learn HBase and start talking about it. Whenever I say HBase, my data is going to HBase, they'll ask why HBase. So this why part will be repeating for every module. Why specifically this? Why not other topic, or why not other NoSQL? Why HBase only? Maybe they can ask you why not you're storing data in other database. Why not in Cassandra? Why not in MongoDB? So we should be able to compare this after getting all the point. So very important. Why? HDFS and HBase. Now think what limitation you have in HDFS. What is not possible in HDFS? So many limitations we have in HDFS. In first few session, we only focus on basic fundamental of HDFS, what they can do, what they cannot do. Now I know one difference, that this HDFS is designed for. I'll change my color. Point number one, they maintain their historical data set. So HDFS is storing the historical data or batch data, not the real-time data. Historical data or batch data, one on the other side, both are same. HBase, now since we're comparing, you know what I'm going to write here. HBase is not dealing with historical. HBase is dealing with real time. And we often say real time. Actually, nothing is real time. We have some fraction of second gap, right? If it is traveling through light speed also, there is some 0.0001 second time they are taking, right? If I'm doing one broadcasting also, right? So you see that somebody is giving a speech recently, uh, PM of India. We have seen uh, any broadcasting detail. Let's say watching a live football. So you see that in TV this is written as live, but this is actually not a live. This is some 5 second, uh, 5 second streaming difference is there. Okay, because they take a time. If you internally want to go with a network, whatever is happening from one TV channel, okay, so they are saying this is live. Actually, they're broadcasting from there. Once the broadcast is done, this information will go to some satellite nearby. Now, this satellite uh, is distributing this information to individual cable operators or different distributor. Then that distributor is operating this to users. Were you? So for this complete communication or data transfer, there are some time gap, 2 second, 5 second. I've seen in cricket, if I tell you, in cricket I've measured also. I download one application in a mobile and I check in the TV. Okay. So there was a gap of 7 to 8 second. What I could see in my mobile application is 7 to 8 second earlier than what I'm seeing in TV. So this is just one live example. If you want to check this, so we do not say real time. We say always this is a near real time, 0.001 second. If I take fraction of second, so historical data and near real time data. Second point, HDFS I have got a limitation, and what is that limitation? I cannot do insert, update, delete, and before that they work with a point of write once, read multiple, right? You can only write once. However, this is different in HBase. We can write multiple, read multiple. Then write once means insert, update, delete. Insert, update, delete. This is okay. Insert, update, delete. This is not working in HDFS. So I'll say not applicable or not supporting because they do not follow any ACID properties, right? However, this insert, update, delete can work in HBase. So this is applicable in HBase. Then fourth point, this is for high latency. So I'm just trying to write the point number one with a different sentence. This is high latency. High latency means data is coming after 1 hour, after 5 hours, after 10 hours, right? Like everyday data, if I'm collecting, I'll take everyday data, which is 24 hours prior data. Okay, so that's what is a high latency. Now, this is low latency. Latency is nothing but a frequency. How soon you're getting data. Like a stock market example, I can take as a low latency because they are changing. They're changing every second. People purchasing flight ticket, people purchasing IRCTC ticket, those are low latency information. High latency is your historical data. So I'll give one quick example on this high latency and low latency. Let's say I am uh, processing on processing data from say election, okay, and in any city, any state, election is happening. Let's say next year, and that election starts at morning 7 a.m. and the event gets completed. This election gets over by 5 p.m. So 7 p.m. starting time and 5 p.m. stop time as an end time. And I will start doing my data analysis, okay, that who is the winner, how many people have voted, what's the total, how many total active or potential voters we have in that city out of 100%. Now I'll say, I'll start my analysis, let's say after 5 p.m., which is 7 p.m. I'm using this time randomly. My event gets completed. Now here's a complete concept. My event gets completed by 5 p.m., but I start their analysis on 7 p.m. This is what? This is the history data now. This is not a real data. You're 2 hours late. So this data is no more a real data now. This is a history now. That's like what I can call a historical. But if I'm doing analysis on every half an hour, okay, this is not just an election. Actually, we perform this in retail store. So in Walmart, we used to count the total transaction after every 10 seconds. How many people are purchasing fast FMCG product, fast moving consumer group product, like daily use product. How many people are purchasing clothes? How many people are purchasing uh, edible items, dry fruits, etc. So when everything has each different category, and based on that, we are accumulating the previous result with the new result. How we're doing that? Here I'll explain you. The same concept we're using in many streaming cases. So when we start Spark streaming, that time we'll see this processing part. Currently, I'm just talking about the storage because HBase is not processing. HBase is a storage. Processing will be done by your streaming process of Spark. So 7 a.m. and I'm giving my window interval of every 10 minutes, okay, or let's say 30 minutes. So 7 a.m. the selection starts and I fix my window interval of 30 minutes. Okay, so 7 a.m. to 7:30 a.m. 7 a.m. to 7:30 a.m. This is my first window, 30 minutes. I will count. Suppose there are 5 different 2 parties, one state party, two individual candidate. So I'll write it as A, B, C, D, E. From 7 a.m. to 7:30 a.m., people who are fighting with each other with some party, what is their total vote share? If 100 people have voted during this time, 7 a.m. to 7:30 a.m., if 100 people have voted during this time, so how many people have voted for A, for B, for C, for D, for E? I'm writing that number. Okay, let's say this is 37, this is 20, this is uh, 21, this is, so how much? 20, 70, 78. Here I'll say 12, here I'll say 10. Okay, now when I see this number, looking at this, I can say yes, in the first lot, A has got a more vote share, 37%. If I talk in percentage, 20%, 21%, 12%, and 10%. This is my first calculation, which I performed in half an hour. Then my second analysis will start at 7:30 a.m. to 8 a.m. The moment I reached this time, when my clock ticks to 8 a.m., automatically my system will start counting. Now, during this time, how many people have voted? Suppose during this time, the total vote is 70 people have voted. Now, again, this 70 people have voted for each candidate, A, B, C, D, E. Let me write it here, A, B, C, D, E. Now, this time, A is getting 11 votes, B is getting 29 votes, C is getting 13 votes, D is getting 15 votes. So this is 40, this is 28, 68, this is getting just 2 votes. Now, I'm not storing this result separately. I'm accumulating this result. So at 8 a.m., I'll say, at 8 a.m., my final result would be this. 37 was my previous, and during this half an hour, 11 new result, 29, 13, 15, 2. So this is the result till 8 a.m., like last 1 hour result of total 170 people from 7 to 8. I'll tell the number. This is 48, this is 49, this is 34, this is 27, this is 12. Same thing I'm repeating in every half an hour, doing this accumulation. This is what is a cumulative result. And the moment this event gets completed, 4:30 p.m. to 5 p.m., this will be my last batch. If I, this is a batch one, this is batch two. You are creating a different batches, and this is the last batch, maybe batch number. So 7 to 5, if I divide in every half an hour, what is the total time we have? 5 plus 10 by 2. This is total 20 batches will be created. So 20 batches, the moment my clock ticks to 5 p.m., I know who is the winner. This kind of analysis is known as a real time data analysis. And yes, I mentioned the term near real time data analysis. Okay, 80% data is real. So near real time data analysis is done maybe after 5 or 1 minute IST, you get the result. Okay, 17 hours IST. So all this information I'm calling as a low latency data which are frequently changing. This is one example of real-time data analysis. Then any other point? Fifth point. Now I do not remember the point for HBase. I remember the limitation of HDFS. So whatever is the limitation, I can handle that in HBase. So I'm just writing against the point, vice versa for HBase. Random reading is not allowed here. Right? Random reading is not allowed. I can do random reading here. So this is not applicable. This is applicable here. So these are the major point, but yes, HDFS can handle large volume of data. If I say in unit, this is zettabytes. I can scale till any number in the cluster. 200 server, 2000 server, 20,000 server. I can scale it. In HBase, I cannot handle zettabyte. I can handle petabyte of data. So this is one difference between HDFS and HBase. And there is out of topic context, I will tell you one more thing. Apache has built one more product, which says HDFS has got some limitation. HBase has also got some limitation that they can handle low latency, not the high latency, then petabytes data. Now, what if I want to get both the properties at one place? So they said we have another tool. So if you're interested, you can read about this. This is a new thing in the market, Apache Kudu. So Kudu is saying I can handle HDFS also, I can handle HBase also, and I can do the job of both. So Apache community is building any module framework in 3 months, 5 months. So things are changing so fast. If you subscribe the news channel of this Apache or the page, you'll get every day new detail that we are building this. This version is updating. This version is new. This version is old, etc. Now, can we go and see table creation or basic behavior of HBase? So HBase also works with the concept of HDFS. There we have master and slave. Here also in HBase we have master and slave. HBase, master and slave. I'll, I'll talk about the architecture of HBase once we know this basic fundamental. Master and slave. Master is HMaster. The name itself is HMaster, and slave here, or worker node, right, is known as a HReason server. HReason server. HMaster, where I'm configuring this now. Suppose I have a cluster ready in my system, that Hadoop system is already built, multi-node cluster. Then how can I set up this services? Where should I set up the services? Should I take a new machine altogether for master and slave? So that's not the case. If your system is already ready with name node, data node, secondary name node, resource manager, node manager, so many services are there, application master, job history server. So HMaster, okay, HMaster will sit with name node. Wherever I have a name node, I'll configure this in HMaster. Okay, I'll configure this in name node machine, this service. And by the way, name node is what? Name node is also master. So if you map it, master is going with master and slave is going with slave. Data node is slave. So wherever I have data node, I'll configure this HReason server on that data node. So my communication can work fluently, okay, without any interruption. Now, to communicate with HBase, a basic flow of name node is what? Client is communicating. So let me talk about that flow also. Client is there. Client is communicating to name node. If it wants to read and write any information, it goes there. And then we have bunch of data node. Data node 1, node manager 1, data node 2, node manager 2, data node 3, node manager 3, data node 4, node manager 4. Likewise, I have client is going to name node. Name node has all their core site XML, topology.sh, topology.data, checking the IP address, and based on that, their responding and giving one acknowledgement to client. Client can communicate to this any of the data node, then this data node are further communicating to DN2, DN3, DN2 is communicating to DN3, and so on. This is a pipeline business, right? But we have a slight different scenario for HBase. We'll see that in architecture part in detail, but here this is important. So we need one management tool here, just like personal assistant of this HBase, if I say in simple term. So that personal assistant is known as a management tool, okay? Uh, Mainly important for admin people who are working as an administrator. Whenever this is a client, okay? So let me change this color. This is a client. There we have H master, and I have my H reason server. So H reason server, I'll write it as HRS, H reason server 1, H reason server 2, H reason server 3. Now, client cannot directly communicate to H master. What did I say? Client cannot directly communicate to H master. Okay. Earlier in Nemnode, this client was directly communicating, but here we have one management tool, and that management tool is Zookeeper. Why I'm talking this Zookeeper as a management tool, I will tell you that. Client cannot directly communicate to this. This communication is not allowed, not configured in HBase. So always this will go through Zookeeper. It will first communicate to Zookeeper. Zookeeper has stored their master service, their slave service in their configuration, in their service management part. Zookeeper will work as what I said. This is a PA, personal assistant. Zookeeper will check, okay, HMaster is busy with so many requests, or we have some slot or some memory computation is available in HMaster. So number of requests is defined based on the cluster. If HMaster is busy, then Zookeeper will say to this client that please communicate after 10 minutes, after 5 minutes, after 100 minutes. So this will pass one acknowledgement. Client knows, okay, the master is busy, I cannot communicate immediately. What if master is not busy? Then Zookeeper will pass this information to HMaster that some information is coming from client. Would you like to serve? So HMaster will say yeah. HMaster will give this information to client, and then client can access this H reason server. This is like very basic picture. Then we have some metas, meme store, some uh, write ahead log well file we call. We'll see that in the detail when we discuss about the complete architecture. This is just one free body diagram. HMaster is giving this information to client, but HMaster can also communicate here directly with your H reason server. So if required, HMaster can also communicate or it pass that information to client. So this is like a request call, and this is an acknowledgement. What if this Zookeeper is not there in place? What if this Zookeeper is not working? If Zookeeper is not there, then you will get exception that client cannot reach to HMaster, or you'll see Znode exception. The exception will come as Znode is failed, or Znode is failing. So HMaster is master service, H reason is slave service. Zookeeper also has one service name, and that service name, I'll write it here, or maybe here. The Zookeeper's daemon, okay? We call often this service as a daemons. So Zookeeper daemon is QPM. If I abbreviate this, QPM stand for Quorum Peer Main. Quorum Peer So they connect P to P. That's why the name they must have given as Kuram Peer main. And Zookeeper is like uh, all the animals we have in Hadoop, like Hive, Flume, everything is related with the name of that. So it is managing, it is keeping all the information of your individual module. So we can call that this zookeeper, this zookeeper is a backbone of Hadoop. However, I do not need in other services, but without Zookeeper, I cannot work with HBase. That's one. So Zookeeper has a separate topic. We'll spend 1 day or 2 day on Zookeeper. So we'll see that in detail, how this Zookeeper can work or working. Next thing, uh, after Zookeeper, client master, reason server, can we go to our Cloudera and see the services? So to see the services, I need to type sudo jps. Okay, my Cloudera is already open, and I'll open terminal. How to go to uh, HBase cell? Just like Hive, you have seen sudo hive. For Impala, we have seen Impala hyphen cell. For HBase, this is HBase cell. So to go inside this HBase, you'll have to type login login to HBase cell. This is HBase space hyphen cell, and this cell is built on combination of JRuby. The cell is built on the combination of JRuby. JRuby is Java plus Ruby. And whatever query I'm writing inside the cell, this is all in JSON format. Whatever query I'll write in this is all in JSON format. JavaScript object notation. And if you ask me what is Ruby, Ruby is a functional programming concept, just like Python, right? Ruby on Rails. 2008, 2010, I have a bit of experience with this, but not so well. So Ruby people work with a functional programming thing. Now the next operation is, if I want to see the table, so all these queries will see. List is for table checking. If you want to come out from this, you can type quit. Can we see the service name? Sudo JPS. You can see the service and identify that all the services are there or not. So I'll check these three services. If this three services is not up, then my HBase will not work. I will check for HMaster. Go one by one. We have HMaster here. Second service, HReason server. We have HReason server here. Third service, Quorum Peer main. We have Quorum Peer main also. So first number you are seeing, that is a PID, process ID, and this is the service name. Where this is all configured, if you're interested to know the config part, this is in user lib again. Everything goes to user lib, HBase, and I directly go to the configuration folder. Same, we have all the folder. If I go back and check, lib is there, all the dependent jar file, then log is there, all the HBase logs are getting stored. Then configuration is there and bin is there. Bin for scripting, configuration for configuration folder. So four things are important: lib, conf, bin. Sorry, three things are important: lib, conf, and bin. Lib for jar, bin for their script, and conf for configuration. I will first go to configuration into lsrd. There's a file name hbase site.xml. All the configuration is there in this file. Open this and see. So XML properties are set, where data will store, where communication will happen, what is the distributed cluster environment mode. So all my data will store of HBase in this place, htfs tfs -ls slash, and this is the username. Now you're thinking, which means HBase is storing data ultimately in HDFS only. So yeah, that's true. HBase need HDFS to store the data because ultimately all this information, right? I built this architecture and just some time back I said HMaster I'm configuring on the machine where I have name node installed already. So name node is configured there. Then this reason server is on data node 1, data node 2, data node 3. So ultimately, HRS is storing their data where? On data node based on the replica and sharding concept. They use the sharding. And collection of data node is what? Collection of this data node is nothing but HDFS. So HDFS provides one separate space for HBase that you can store your data to this file system. Now, we have not seen the architecture, which will start on Monday, and whatever theory concept we build today will practice this points, mainly this point. How we can do insert, update, delete, how we can handle the real-time data, how can we handle the petabytes of data, how can we scan the data, how can we run a query, how can we do filtration. One limitation is there, only the joining we cannot do in HBase. Okay, so joining cannot work in HBase. And if you know HBase, you will by default understand Cassandra. It's either case. If I know Cassandra, I know 80% HBase. If I know HBase, I know 80% Cassandra because both are using the same concept. Similar, they work with the concept of key and value. There's also a key and value. There's also a key and value, but in cloud side. There's also a key and value defined by LinkedIn. This is for document, we know. CouchDB is also for document. This is for graph data. So based on the data set, we need to know what type of data. But I have worked on Cassandra also. So Cassandra is very similar as RDBMS. In fact, if you know RDBMS so well, you can learn this Cassandra